question asks us to predict the products of these halohydrin formation reactions to look at the stereochemistry of the product when we start with diastereomeric alkene starting materials. We'll start with the E-alkene. The mechanism and the process to form each of the products is the same, so we'll go straight to the product. When we draw these types of products, I like to keep the northern hemisphere to stay in the plane and do the stereochemistry in the southern hemisphere. That will put the ethyl group on a wedge. The oxygen will attack the most substituted carbon to give us the most substituted alcohol. There is anti-stereoselectivity in this reaction, and so we'll get the anti-stereochemistry between the oxygen and the bromine. And this will be the product of the reaction with the E-alkene. This product would form as a mixture of enantiomers. Let's look at the Z-alkene. Again, we'll keep the northern hemisphere constant in the plane and use the stereochemistry in the southern hemisphere. The methyl group will go on a wedge. The oxygen will attack the most substituted carbon, giving us, again, the more substituted alcohol. The anti-stereochemistry of the reaction gives the bromine on a wedge, and the hydrogen is still on a dash. And this product will also be a mixture of enantiomers. So these are the two products of the halohydrin formation. It's a little bit hard to compare these two products, however, because they're not quite drawn in the same rotation. So what we can do is let's rotate around this carbon in order to bring the ethyl group into the plane of the screen. When I do that, the ethyl group will move into the plane of the screen. The carbon on the right will stay the same. When I rotate that ethyl group into the plane of the screen, the methyl group will rotate back and take the place of the oxygen, and the oxygen will rotate forward and become on a wedge. Now these two structures are drawn in the same rotation, and we can compare their stereochemistry. The carbon on the right stays the same. The carbon on the left, however, changes. This product, still a mixture of enantiomers, has one stereocenter that's the same and one stereocenter that's different. These products then are diastereomers of each other. We form diastereomeric products when we start with diastereomeric alkene starting materials in this halohydrin formation reaction.